Okay. This is where we get all the power for solving these things. So it does kind of get exciting. I personally haven't looked at logarithms in, I don't know, 15 years or something, because I haven't taught this course. So I remembered liking them, but now they're just so neat to use and to solve and to simplify things that I think if you have an open mind, you can think they're a little bit fun in terms of math in general. Okay, the main thing to look at, and I talked about this in 8.3 a little bit, is that logarithms have laws just like exponents have laws. And because logarithms are the inverse of exponents, exponential functions, the laws are very related. So basically on the left, I've listed 3 exponent laws, which were the 3 basic exponent laws that we learned. Okay, so you actually learned these in grade 9, that when you multiply 2 values with the same base, you add the exponents. When you divide 2 values with the same base, you subtract the exponents. When you have an exponent to an exponent, you end up multiplying those 2 exponents together. So this was very basic. You know, within the first couple days of coming into grade 9, we were throwing this at you. And you ate it up and you seemed to understand it because it makes intuitive sense. We showed you a proof and away we went. Well, we could do the same thing and show you logarithmic proofs, but better to understand that these are inverse functions of the exponential. So when you look at this specific exponent law, okay, which was called the multiplicative law, it also has a multiplicative log law, but it's in the inverse way. So when you have logarithm base a and you have 2 values being multiplied here, m times n, you can break that back down into 2 logarithms, both with base a, and the addition of them. One in terms of m, one in terms of n. So it's actually going in the opposite direction. And because it's an inverse, so they're interchanged. Same, there's a division log law. If you are looking at a logarithm base a with a division in it, you can split it up into 2 base a logarithms and the subtraction of m and n. Okay? And then this one actually is a little bit sneaky, and it becomes the most powerful one, I think. This is the one that you'll use quite a bit, because it transitions a lot of things really nicely. So you have a log base a of m, and that m is to the exponent y. What you're able to do is pull this y out front. Okay, so that exponent there. So if you can write whatever this value is in here in terms of an exponent, you can pull the exponent out front and you're still left with the logarithm of m base a. So basically all that's happening here is this y, whatever this exponent is here, is being pulled out front and being multiplied by the logarithm now. And it's kind of a sneaky little law that you don't always see to use it, but makes your life quite a bit easier when you can use it. Okay, I seem overly excited about this. Okay, so these 3 basic examples. We're not solving, we're just evaluating, and they're not difficult. This is just a warm-up basically to see what we're doing. So you recognize right away these have the same base. That's the key of all of these things. They must have the same base. These are both base 4, and I'm adding them. Well, if I'm adding 2 logarithms base 4, I can write them as a single logarithm base 4. And what I end up doing is taking the 2 values that were here, the m and the n, and multiplying them. So this really becomes 32 times 2 inside that bracket. So that's equivalent to log base 4 of, what's 32 times 2? 64. And then remember, you're asking yourself, in a little thought bubble, 4 to what exponent gives me 64? That's how I solve that. Well, 4 to the power of 3. Okay? Not overly difficult. Just as a way of showing you what you can do in terms of this being a little bit sneaky, is you could change this to be rewritten as log base 4. Now 64 I can rewrite as 4 to the power of 3. So then I can end up using this, I can use this law and bring the 3 out front, and log 4 to the 4 is obviously just a 1. So you could have went 2 different ways. You can just solve it normally, or you can put it in exponent form, bring it down, log 4 to the 4, obviously base 4 is a 1, and you still get an answer of 3. Oh, my hand is cold. Okay, when you are looking at a subtraction one, the same thing applies. The key is to make sure they have the same base. Okay, whatever it happens to be. So these are base 2. So I know I can take a subtraction of two things with the same base and change it into a single logarithm. I look here, how do I do that? I divide the m and the n value, which in this case are 18 and 9. So this will be the division of 18 and 9. So this really becomes log base 2 of 2, which is just 1. Okay, 2 to what power gives us 2? Obviously a 1. Okay, the last one, and this is where you have to start thinking, I have no idea what I'm doing here. What's going on? Well, first thing, if you see radicals, get rid of them, change them into exponent form. That makes your life easier. So this root symbol, remember, is just 8 to the 1/2. And again, that doesn't necessarily help us a ton. But what I would say is, if you're having trouble seeing, as soon as you get an exponent in here, use this law. So this is our y value is 1/2. We can bring that out front like this and still be left with log base 2 of 8. Okay, so really what's happening here is I leave the 1/2 out front. This is being multiplied. Well, what do I know log base 2 of 8 is? Remember what I have to say here. 2 to what power gives me 8? 2 to the 3. So I've replaced log 8 base 2 as a 3, and I can just get an answer of 3 over 2. Okay, so I've applied, in a way, all three of these laws once in their most basic form. Not overly difficult. You just have to get used to it, sort of like a new language. Do a couple examples, and you will get better at it. Okay, the ones that we really want, though, the examples that are the best are the next two, and they show you the power of these. I'm going to leave these laws up. I'm just going to erase this, what I have in purple, to do the next two examples. And I'll probably write them both separately. So the first one is, this is now something you're solving, so it's a little more interesting. Log x base 3 equals 1/2. Let me just make sure I get this written down right, or it'll be a disaster. Okay, so it looks complicated. The good thing for us right now is everything is base 3. So we know we can start doing some things. So there's a couple strategies that you want to use to solve these. One, if you're solving for an x, you want to make sure that the logarithm that has the x attached to it is on its own on one side of the equation. So this one's already set up in that way. So we're happy to leave that here. Okay, the next thing we want to do is if there's ever a number out front, like being multiplied by a logarithm, we want to use this law backwards. Like, we don't want this number out front. We want to put it back into the logarithm so that we can use these laws. Notice these laws don't have numbers out front. Okay, the number out front's always a 1. So what we want to do right away is we're going to leave this here, but we're going to bring the 1/2 that's currently out in front back up to be the exponent on our m value, which in this case is a 36. So all I've done here is take the 1/2 that's out front and put it back up there. Okay, so I'm just using this law in reverse. And then I'm going to leave these as they are for now. I'm going to do it nice and slow, one thing at a time. For those that are really paying attention, you're starting to see a bunch of, oh, I can use that division law with that subtraction. Oh, there's an addition, I can use the product law. So you can see them developing. What makes your life easier is to simplify within the steps. So if I look at this and I see 36 to the 1/2, that means the square root of 36. Well, I know the square root of 36 is 6. So I might as well put that in. So basically, this little expression here got simplified quite a bit to this. Now that is being added. I can't simplify this at all. 3 to the 18 minus log 3, 2. Okay, so now it's just a matter of applying the other laws. Leave the x on its own till the very end. So what I'm going to do here is first look at the addition law. Okay, so here I have an addition. What do I do with my m and n value? I multiply them. Keep it base 3, and I'm going to multiply 6 and 18. Now I still have, don't forget about this poor subtraction here at the end. So I now get, what is 6 times 18, 60, 100 and, 6 times 8 is 48, 108? Yes, 108. Okay, and once I have that in there, I go, oh, well, now I have another logarithm law. This time it's the kind of the quotient law of logarithms. So when I see a subtraction, I can take two logarithms and reduce them to a single one.